Hello everyone, welcome back to the workshop. Today we have something really cool to look at. This is the Glacier. This is the 120 watt water-cooled diode laser from Atomstack. They sent out one of their prototype machines so that I could give it a bit of a rundown in the workshop, give you an idea of what it is capable of, and see what I think about it. So we're gonna be putting it through some tests of some materials I would run through my workshop, see how it does, maybe do some detailed tests, kerf tests, things like that. So if you're interested in finding out more about this laser, stay tuned, I'm gonna jump right into it. So as I mentioned, this is a prototype of the production machine. Both the Glacier and I received these prototype models to do some testing and such with it, give them some feedback, and also give you a preview of what to expect from this machine. We've been talking with them about some improvements and adjustments, and so it's going to be very similar to this. There may be some tweaks and differences, and all that should be for the better for you. As far as the build goes, it is very, very similar to the A70 frame that we looked at earlier. It is 20 by 40 extrusion, and then bolted together with the various cap head screws and such. So if you're familiar with that one or want to look at some of our other videos on that, go ahead and take a look. You'll see a lot of similarities. The transmission system is kind of the steel wheels on rails. That is a decent way to do it. I'd love to see on some of these higher end machines, maybe more linear rails being used. Just gives it a bit more rigidity, but they seem to be working pretty well. This is, of course, a lot larger than the A70 Pro that I looked at. This is the max version, and so the working area is 800 by 800, but I had to build up this table, my assembly table, to just be able to support it. So front to back here, we are using basically 4 feet of front to back. Side to side, maybe a little bit less. We're somewhere around 42 inches just for the clearance. However, one of the changes that you're gonna see from this model to the production ones is this cable chain on the side here. That is gonna get out on the outside of here. As it is, it just kind of hangs down a little bit and could interfere with your honeycomb. So that's a change they are already making. So that's gonna make the width a little bit wider. And then of course you do have the control box up front. This does get bolted to the frame, but it wouldn't have to be. It just bolts in the front, so you could move this on the outside of a custom enclosure. And then you do have your air pump. This is the typical Atomstack. I believe they call it like the F60. It is a really nice air pump, works very well. Happy to see that in this one as well. It is controlled through the controller, and so you can turn that off and on within the software. And of course, the big driver of this is the chiller. So this is the chiller right here. As you can see, it is rated at 300 watts, cooling capacity of 420 watts, keeping it right around 25 degrees centigrade. I've noticed that it does stay within a tenth. Generally, it's just sitting idle, but even while I was operating it, very little variation in that temperature. It keeps it fairly consistent. So you do have to add some, at least distilled water. You can add some antifreeze with a ratio of a glycol lower than 30%. Ethanol as well is optional. I'm just using some distilled water, and they do have a nice visual up front here. If you can see that, our water level is right around half. It's a good spot to have it in there, but you will need to fill that up. It does make it a nice sealed system, so it shouldn't have any dust or algae growing in there, but you could add just a couple drops of algicide to keep it clean. And then of course on the side, we do have our vents. These are filters. You will have to clean from time to time, but in there, you can kind of see maybe at the back, we have the actual radiator that's hooked up to the compressor in here, doing our active cooling. Around on the back side, we can see we do have our serial data cable that needs to go up to the control box. A couple of fans that are moving air in and out, power switch, power cord, and then our inlet outlets. They do provide plenty of hose to be able to move this around. The shortest connection would be your serial cable that does come back up into the control box. But all that being said, this is fitting onto basically a 4 foot deep by 5 foot wide table. You would need that, maybe a touch more, especially if you're going to connect a laptop to it and want it in that same space, to be able to really contain this well and support it. So that's going to be one of the things looking at this laser. it does take up some space. It's got a large working area, but then it also has a large frame. Personally, for my use, I would love if it was maybe 2/3 this depth, maybe bring it back to about 500-ish millimeters, and then keep it 800 wide. Just that's my style. It works easier into workshops. And quite frankly, if I have this up against the wall and I move this all the way back, some of my items, and I'm pretty tall, I'm about 6'4", 6'5", reaching them is going to be an issue. So it's just very large. You almost have to be able to work around the sides. So I would love to see just maybe something a little less depth. They do still have their touch panel screen, and they do have a USB port along the side of the control box, so you can use it offline, but it is compatible with Lightburn, Laser GRBL, but they also have their own software called Atomstack Studio. That has been working with a lot of their lasers lately. It's a nice way to get into it without the extra cost of Lightburn. And there are some caveats between the two. There are some macros you need to use with this one to get the full functionality of it, but they're working on pretty good integration with Lightburn. So I haven't had anything that I haven't been able to do with this machine in Lightburn and haven't had to use Atomstack Studio. So if you are a Lightburn fan like myself and want to use that, so far, everything has worked very well.
All right, taking a closer look at the control box. You see that it is a lot larger than your typical control box we've seen on these, but a little bit more going on there. I do like the layout of things. Over on this side, we do have a power switch, our power plug. This is a serial cable coming from the chiller. And then down here, you see we have power out going to our air assist, and they do have an optional fire safety. So looks like they're looking at an add-on for that as well. Up top, we do have some status lights here. So I do have it powered on. You see that it's got a status light for temperature, so that should be green, assuming that it's seeing the right information coming from the serial cable that the temperature is within check. It will show that if it's seen that there's active cooling again through here. If any of these get out of check, it will throw a bit of a different color. It might turn amber or red, and just give a warning that something's not right. This does connect via Wi-Fi and Bluetooth to at least Atomstack Studio through the computer and through Bluetooth through the mobile device. And so that will flash if it's trying to connect, and should turn blue if it is connected. Status is just green. Here is just sitting idle. If it's working, you might see it flashing and such. And then they do have an autofocus button. So this module does have a probe. We can take off this shroud, and you can see that over on the side here. It will touch off of the material and then set back however far it needs to go. One nice thing about this module is this dovetail does go top to bottom, so you have a lot of adjustability in how high or how low you need to take that. So depending on what you have this sitting on, it can be a nice benefit to you. But the autofocus does seem to work pretty well. Moving back to the panel here, we do have a USB key. So this you can remove it, and then it would lock out the device. So it's an extra safety feature that if you want to be able to disable the device without completely disconnecting things, you can just remove that, but you will need that in there to operate that. Of course, one of the things that's very critical on any of these devices is an e-stop button. They have it right up here on top. I love that there is nothing in the way of it. So if you ever have a problem, you can just hit that. And as you can see, it killed all power to the laser. And then if we twist it, it will boot back up again. Everything should come back online. You see our status lights coming back. We're good to go. Over on this side, we do have a few more ports. We have USB driver. That is for a flash drive, a USB thumb drive. You can load your files on there and then access them through the touchscreen. We do have a USB-C cable to go to the computer for direct connectivity. And then we do have an accessory port. So probably things like rotaries and such that can be added to this. And then of course the HDMI cable to our touch panel. The touch panel is pretty typical of all of our others. If we had a drive in there, you'd be able to load up files. Otherwise, we can get at some basic settings, turn them off and on. So taking a look at the module, we do have our water lines coming in and out for the active cooling. It is all sealed, and this is one of the big features of water cooled is that you don't have that air cooling fan up top blowing in air to keep it cool, which is also going to be pulling in any dust or smoke or vapors. This will keep this working a lot better. It'll keep your maintenance down, and the water chilling should keep that running in spec. Over on the side, we do have our communication and power cables to the module. and those all going into the cable chain. Cable chain is a lot bigger than we've seen on other lasers due to the fact that it does have to add these water lines to there. We do have a quick disconnect in case you need to swap this out. They do have an IR module coming out for this as well. So having that quick disconnect is going to work really nice in not making a big watery mess anytime you go and change that. It is a powered Z. You can kind of see our stepper motor there and knob that we can make manual adjustments to if needed, or it is powered and addressable through the software. So comparing this to the 70-watt module, I'll just set these up kind of in place. You see it is very similar in size, in fact, maybe a touch smaller. Of course, this one having the big fan up top. And I haven't weighed them, but I have a feeling that that one actually feels a little bit heavier than the water-cooled module as well. So didn't get a big increase in mass or weight to add this water cooling. Of course, the water itself is going to add a little bit of weight, but going to outweigh by the benefits of much more consistent cooling.
So what you're really probably interested in is how did it actually perform? So I did run it through a number of tests, and one of the most common tests I use is 3mm or 1/8 inch Baltic birch plywood as kind of a baseline against any other laser. It's a material I've used in my shop for quite a few years, and so for me, it's a really good baseline of how a laser compares to others, and so let's take a look at that. So I ran a number of tests, and this is kind of the average of where it fell out. And so I set up this up in Lightburn. We're running from 15 to 22 millimeters a second, and from 70 to 100% power. And since it has that powered Z axis, I did set the focus down 2 millimeters, since this is 3, just to try to get that focal point more towards the center of the material. I did have some tests where it was higher, some tests where it didn't get through at 22, so I kind of felt that this was the average. And I never usually base it off the absolute extreme that I get to. So if it cuts through at, say, 24 at 100% power, I'm still going to back it off. So for my tests, I'm going to be running around 20 to 21 millimeters a second, this is with full air and that 2 millimeter drop down. And you see on the backside, fairly clean. We are seeing a little bit of staining on here. And that's one thing I found with this laser is it would really function a lot better with more area underneath the cutting area, and especially if you can have some airflow underneath there. So something to consider if you're looking at this laser, you may want to adjust your work area, maybe build in a downdraft table of sorts just to get that the smoke and vapors away from your material. But pretty happy with how that came out. So let's step it up to 1/4 inch. So I ran these tests with both the settings, just this typical 100-watt normal mode, and this was the result. We were kind of squeaking out at 100% power, both in 21 and 22, and then dropping into lower in the 80s and 70s as we go down. But then this was in turbo mode. We did get through a little bit more, and if I stack these, you notice like this one is gone. So we are getting a little more power out of it at that setting. I could probably run this a few more times as well and get some differences. Looking at the back on the 100-watt, you can see these are almost punching through, but there's just some little areas hanging on, and kind of the same thing here that would have gone through at 90% power on this one. I could probably punch that through, but I try to leave this to mostly just dropping out on their own, or if they just tap out. If they're being held on by fibers, it's kind of a bad test because the more you see of that on a larger cut, you could find yourselves with a lot of areas that didn't cut through. Let's look at true 6 millimeter or 1/4 inch Baltic birch plywood. So I ran the same test at the same speeds. This one from 15 to 22 millimeters a second. Again, 70 to 100% power, and nothing broke through. And as you can see here, really wasn't even close. Maybe down here at the 100% power and 15 millimeters a second. Slowed everything down, went from 70 to 100% power in 9 millimeters a second up to 14, and there we were cutting through. Getting through at 13 and 100% power. Really in this one, I'd probably back it off to 10 or 11 millimeters a second, but getting through, and backside again, fairly clean, but as you see, as we slow things down, we're getting more of that vapor and staining on the backside. Elevating it is going to help you out a lot, and also keeping your speeds up. So taking a look at the Glacier compared to the A70, wanted to do a comparison test here. Did both a speed test cut, and on the A70, we were getting through this material at 18 millimeters a second from 70 to 100% power. And there may have been some areas where it could have punched through here, as you can kind of see. There may be a bit of an imperfection in this material, but I wanted to keep it on the same sheet of material to see as close as we can. And then of course the Glacier, punching through all the way up at 22 millimeters a second, 100% power, and this is at the turbo mode, the full 120 watts. And so definitely some increase in speed from going at 18 all the way up to 22. So about a 20-ish% increase between the two lasers. Now, the interesting thing being, I also ran kerf tests on these. And after crunching the numbers, the overall total kerf line, the total material removed after subtracting, averaging them out and subtracting or dividing by 2, both kind of ended up right around 0.25 millimeter for the line. And so we'd be looking at a kerf offset of 0.12 or 0.13 for both of these on the same material. And so I probably using some similar compression technology, maybe improving it on this module itself, and also that more efficient burn of the 120 watt is probably going to have less overburn on your top layer of the material as it tries to cut through. It can go through faster, it's not lingering, it's not going to be burning as much. So not exactly a big jump up in kerf. The basic gist of it is we're not seeing a huge jump in the spot size, the kerf size on the 120 watt module, at least over the 70. If I compared this to say the A40 or something smaller, definitely is going to be a thinner spot size, but you're going to be struggling to get through material such as this with that laser. Did go ahead and grabbed, this is some 1/2 inch material from Home Depot. It's the Pure Bond with kind of the nice veneer side, and did do some testing. So started out here with my initial test from 10 to 17 millimeters a second. Did drop the focus down about 6 millimeters and ran it from 70 to 100% power, but didn't get through it all. As you can see, nothing coming through on here, but again, a different type of material. Those glue layers and the interchanging kind of grain patterns are going to have an effect on this. So did run another test, and this one it ran from 5 to 9 millimeters a second, and we did start to get through there. You can kind of see there, even up at 8, punching through at 100 on down to 5 millimeters a second. However, if I flip this around, you're going to see it's pretty ugly on this side. Getting a lot of flashback and burning, and just a little bit sooty. I mean, my fingers are getting sooty just touching this, because we did cut this outside out at 5 millimeters a second. So it is possible, but at those speeds, you're gonna have kind of an ugly cut. So with that information, you'll see I have a couple of square holes here. I went ahead and ran the square at 6.5 millimeters a second, single pass, and it came out not terrible. Tried to get it as about as fast as speed in one pass as I could to keep that beam moving. But as you can see, we're still getting that kind of sooty background to it. So then I went and jumped up to 14 millimeters a second, but 2 passes. It's still cut through. Our edges are similar. The back is looking a bit better. So here are the two side by side. The front looks similar, but the back, you can tell, is way cleaner. So this is a case where, yes, it can cut through at those speeds, but increasing your passes may make a difference. The edge quality is about the same. If I can get that to focus, there you go. So there's not a big difference there, but the quality of the back, and if I show you this one, you can obviously tell the bottom one was done at the slower speed and the top one much faster. So it's not always about getting through it in a single pass. And at 14 millimeters a second, it's still moving pretty decent. I don't feel like it's unreasonable, but starting to look like maybe 1/2 inch plywood is maybe the reasonable spot to stop. And any thicker than that, you're gonna wanna limit it. It's gonna have some extra cleanup and such. So they do advertise that this can cut through 25 millimeter basswood in a single pass. I don't have any of that available to me, but I was able to find some 3/4 inch aspen, which is very close to that. And did run a cut test here again, single pass, and just getting through at 6 millimeters a second at 90 and 105 from 70 to 80. But I was seeing a lot of flame and popping. I was igniting those gases. And this is even with it elevated up above the honeycomb, like a good 3/8 of an inch. And so looking at the back here, it's pretty ugly. So again, it can get through in one pass, but you're going to need to elevate it. You're going to need to work on that airflow, and it's obviously going to be better at multiple passes. The other thing being is spreading that out. When it lingers in one spot, it's not great. So I ran another piece just down the edge from it. Here are my cut tests. So I did 6 millimeters a second one pass, and then tried doubling down to 14 and 12. Now the 6 millimeter one did cut through. It's actually fairly clean. It's caramelized, but it's not overly sooty. And then the back is looking okay. There's a little bit there, but nothing too bad to clean up. But the other two didn't actually cut through. And then the back side there, you see, this is flashing up against this was off the other side of that other cut. So kind of ignore that. But the back on this one was fairly clean. So in this case, with this kind of even grain, there's not a lot of heavy grain to this piece of material. It did cut through fairly cleanly in a single pass. So you're going to do a little bit of playing with that, but realistically, I would probably run this at 10 millimeters a second, 2 passes, just to keep everything moving through, and then be able to cut things like this out if needed. So the final thing I wanted to address is, I know a lot of people are going to be concerned about the higher power not being detailed enough. Well, in this software, you can choose the power level, or in Lightburn, you can switch the macro to drop it down. So you can drop it all the way down to a 40 watt rating and be able to do some engraving from there. So went ahead and did that and ran this train photo. I could have done a little better job adjusting the contrast on here, but the detail coming through on here is actually quite nice. Just lost it a little bit here in getting a little too dark with the settings. But if you look at that smoke cloud and the steam down here, the cattle catcher and everything, looking pretty good and still capable of doing some nice engravings on here, because they do have that software switch to bring the diodes down, not using all of them for when you need more detailed. So just because you jump up into a higher wattage laser doesn't mean that you're sacrificing all the detail. I think for this, if I did a little better photo manipulation, get a little more detail on this, I'd be very happy with this. And thing I always have to remind myself as the creator, I tend to be more picky about it than the person I'm giving it to or the customer. So just keep that in mind, keep a balance there, but nice having that ability to drop it down and still get some detail. So those are some of my initial tests with this prototype machine. I'm kind of having some fun figuring it out. I am hoping that they get the enclosure sent out, because it's fall time here in Minnesota and it's gonna quickly come into winter. And I've been having to keep my door open, my garage door open, and kind of move a fan to move the smoke out. And once the weather gets too cold, I won't be able to do that. So looking forward to checking out the enclosure and how it works with this. But wanted to give you some of my initial impressions of it, where they're at with this, in case you want to get in on that Kickstarter, a little more information for you to digest on if this is something that might work for you in your workshop and upgrade your working space. If you have any questions about this or things you would like to see test, drop a comment down below. Tell me what you think of the overall size. Tell me what you think about the power rating. Is this something for you? And we'll take all that information and maybe jump back here with some project videos or additional tests. Also, go check out David's channel and his video on this. And then if you have additional questions, want them answered right away, jump on Sunday night, 7 p.m. Central. We do a Sunday night live on YouTube, on our Facebook pages, and we do take a lot of that to answer your questions directly. So we've both got this laser. We can both help answer your questions. Hope to see you there. Otherwise, hope to see you in a future video. But most importantly, I hope you get in your workshop and make something too. We'll catch you next time.